Okay, so um, we're given a question here. It says determine the equation of both lines that are tangent to the graph of f at x square. So essentially, it's a parabola quadratic function in its basic sense, and of course it has its origin at 0 at 0. So and it says the both lines, that are tangent to the graph of f at x, x to the power of 2. Uh, it says, it also passes through the point 1, -3. So, well, one thing you have to note here is that, the point 1, -3, that's not a point that, that's on the parabola. If you plug in 1, obviously, y value becomes 1. So how do we go about doing this? Well, first of all, we can graph this, draw a rough sketch, just draw a rough diagram. So you know so just draw a rough diagram. So as you can see on the on the graph, there's the point 1 at -3, and there's two lines you could see. It's passing through, it's passing through in a way that it touches the parabola only once. So it's the lines are basically tangent to the x squared. So in this question, we have to make use of the limits, the instantaneous rate of change, basically a derivative. So f f at x, limit as h approaches 0, we have the standard derivative formula, and it works out to 2x 1. We'll call it x initial. So that's basically a slope, and the m, obviously, it's the basic linear equation slope. So m equals to 2x initial, and it also passes through a point on parabola x initial at x initial squared. So y initial equals x initial squared, and obviously we know there's a point, so the known point is 1 at -3. So well, for m, we have to um, put out the basic slope formula, which is 1 y minus x initial squared, x minus x initial. Okay, and then we manipulate it algebraically, and we get 2x initial brackets x minus x initial bracket, and then equals to y minus x initial and square, and then plug in the known xy value, which is 1 comma -3. So you have 2x initial, and then well, you could see it works out to well, I'm just gonna skip ahead. It works out to the x initial squared minus 2x initial minus 3 equals 0. So if you work out your quadratic formula to find the quadratic zeros, it gives you two x values. So now these x values, they're the values you have to plug into the f at x x squared, and by plugging these in, it gives you the points. So for example, plug in -1 into the f of x squared, it gives you 1, and you also have +3, and you plug that into the x squared, it gives you 9. So yeah, okay, and then what you have to do with these 2 points. So in a way there's 3 points, right? So one is already the x and y value that's given, which is 1 and -3, and the other 2 values. So from these 3 points, you could essentially make the the linear equation. So okay, so the 2 points, you have to make the slope out of, or the -1 and +1 and 1 and -3. It gives you the slope of value of -2, and then you also have the value of 3, 9, and of course the 1 and -3 gives you a slope of 6. So plug that into the equation. Okay, you gotta have to just plug into the just the standard linear equation. So y 1 equals to -2x plus b, and then plug in the point, which is -1 and 1, and it gives you the y intercept value of -1. So same procedure for y2. You plug them in, and it's gonna give you these values. So y2 equals 6x plus b. Plug in 3, 9, and the y-intercept is -9. So in this case, it gives you y2 equals to 6x minus 9.